Okay, so very good morning to all. And let us discuss about the topic of theory of thin film growth. Yesterday, actually, we discusses few of the points, that is the absorption, surface diffusion, chemical bond formation. Okay, now today we are planning to cover the topic of nucleation. Actually, during the thin film growth formation time, nucleation is one of the very important process, very important point, very important steps during the formation of thin film growth. Okay, so what is mean by actually nucleation? What will happen exactly during the process of nucleation? That concept we will try to understand in our today's lecture. Okay, so nucleation means what? The nucleation is the initial process. What will happen exactly? Listen carefully. Nucleation is the initial process that occurs in the formation of crystal from solution, that is liquid or maybe a vapor, in which a small number of ions, atoms or molecules become arranged in a pattern characteristics of crystalline solid, and forming a site upon which additional particles are deposited as the crystal grows. Okay, so we can easily see the this 4 number point. Okay, that is this one. Okay, so whatever I uh, explain the definition of nucleation, so what will happen exactly? The some kind of liquid or vapors in which small number of ions, okay, whatever we are going to deposit it onto the surface, that uh, that are ions, atoms or molecules become arranged in a pattern characteristic of crystal solid and forming a site upon which additional particles are deposited. Okay, so we can observe here, uh, here is the two particles, but here additional particles are deposited. Okay, it means which additional particles are deposited as the crystal growth, or we can say that crystal grows. Okay, so that here we can say in short, phenomena of formation of stable nucleus, that is called nucleation. What is the short definition? That is the phenomena of formation of stable nucleus, that is called a nucleation. Okay, so what will happen exactly? The initial process that occurs a formation, what we already discussed. These are the initial stage or initial process when the nucleation was happening. Okay, and if we talk about the process of nucleation or types of nucleation, so nucleation is the birth stage of film. Okay, keep in your mind that, or we can say that uh, you have to remember the point of nucleation is that the nucleation is the birth stage of film. Okay, whatever amount of material are deposited onto the substrate of a surface. Okay, so that initial stage of film is nothing but a nucleation. Okay, and is essential a problem of vapor solid phase transformation. What will happen? The vapor phase, solid and vapor phase transformation. Okay, and due to that reason there are two stages in the crystallization process was happen. Okay, so in the first nucleation stage, a small nucleus containing the newly forming crystal is created. During the process of first stage, what will happen exactly? Small nucleus containing the newly forming crystal is created. Okay, means whatever we are going to deposit it onto the substrate of surface. Okay, that particle, that ion, or we can say that materials are the newly forming crystals. Okay, which are going to created onto the surface of that substrate. Okay, so it might be possible, it might be possible the, it is a stable film, nuclei at a critical size is needed. Okay, so what will happen exactly for embryos smaller than this? Okay, smaller than this means the atoms may be a smaller. Okay, so what will happen exactly? The surface energy is too large and the overall reaction is thermodynamically unfavorable. Okay, if I'm talking about the critical size are needed. Why critical size are needed? स्टेबल फिल्मसाठी क्रिटिकल साइज का गरजेचे आहे? बिकॉज फॉर एम्ब्रॉइज स्मॉलर दॅन दिस, ओके, द सरफेस एनर्जी इज टू लार्ज, द सरफेस एनर्जी इज टू लार्ज and the overall reaction is thermodynamically unfavorable. And if we talk about the second point, so the point is the stable embryo is one which adding more molecules decreases the Gibbs free energy. Okay, so you have to keep in your mind that during the process of nucleation there are some thermodynamic process was happening. Okay, so here you can see the first sentence. Okay, it means that a small nucleus containing the newly forming crystal is created. So nucleation occurs relatively slowly as the initial crystal components must impinge on each other in the correct orientation and placement for them to adhere and form the crystals. Okay, adhere means at that time the adhesive force are applicable. Adhesion means what? The some same kind of materials are interacts with each other. Adhesion, that is adhere. It means the two atoms or two molecules or two ions, they are bonded with each other, they are stuck with each other. Okay, and after successfully formation of stable nucleus, after successful formation of stable nucleus, a growth stage was started. Okay, and that in that stage is a free particles, and that free particle, it might be a atoms or it might be a molecules. Okay, and that particles might be possible to adsorb onto the nucleus. Okay, and that propagate its crystalline structure which outwards from the nucleating sites. Okay, and that's why here the process was happening whatever we discussed recently. Okay, that this is the nucleating sites. Okay, this is the nucleating sites, and in this site what will happen? The particles adsorb onto the nucleus. Okay, whatever particles we are going to deposit it, that particles are adsorbed. Okay, and propagate a crystalline structure outward from the nucleating sites, and this process is significantly faster than nucleation. Okay, and the reason for such a rapid growth is the real crystal contain dislocations and other defects, which acts as a catalyst for the addition of particles to existing crystalline structure. And this is the first stage of what? This is the first stage of crystallization process of nucleation. Okay, so generally during the formation of crystal growth or during the formation of nucleation, there are two things was happening. Okay, it means two process was happening, and that process is nothing but a what? Nucleation can be either a possibly homogeneous or might be a heterogeneous nucleation. Okay, so nucleation can be either homogeneous. So how the process of homogeneous was happening? Because the without the influence of foreign particles. Okay, foreign particles means whenever onto the substrate the nucleation process was happening, when if the extra other particles cannot be attracted towards the substrate side. Okay, it means it not it may be means we can say that in easy language, there is not allowed any other particles to form a homogeneous nucleation. Getting my point? Homogeneous nucleation means what? Without the influence of foreign particles. Means in this case, it is not required a external particles, which particle can came into the substrate side and form a nucleation process. Okay, so that's why the sentence indicates, that's why the sentence indicates the without the influence of foreign particles. Okay, there is no not needed a foreign particle. Foreign particle means other extra particle. That particle came from the other side, okay, or maybe in a external side, okay. And heterogeneous nucleation is nothing but a influence of foreign particle, means the heterogeneous nucleation process was happening due to the reason of external particle, which particle came from the outer side, okay. So these are the uh, distinguish process or distinguish between the heterogeneous nucleation or homogeneous nucleation. So generally, if we talk about the heterogeneous nucleation, then the heterogeneous nucleation takes place more quickly since the foreign particles acts as a scaffold for the crystal, okay. And during that process time, the crystal was grown on that surface, okay, and thus eliminating the necessity of creating a new surface and then incipient surface energy requirement, okay. So this is the heterogeneous about the nucleation. So heterogeneous nucleation can take place by several methods, okay. Look it carefully and listen carefully. The heterogeneous nucleation can take place by several methods, and some of most typical are small inclusion or cuts in the container the crystal is being grown on, okay. So it might be possible to cut that particles, okay, or in the container uh, inside the system where we are going to deposit it a thin film, okay. And this include scratches on this side and bottom of glassware, okay. And a common particle is a crystal growing is to add a foreign substance, such as it might be a string or a rock to the solution, okay. So this is all about the homogeneous nucleation, okay. And the number of nucleating sites can also be controlled in this manner, okay. It means that the process of homogeneous nucleation, we can control that number of nucleating sites can be controlled, okay. And if this brand new piece of glassware or plastic container is used, and the crystal may not form because due to the container surface is too smooth to allow heterogeneous nucleation, okay. On other hand, if we think about the badly scratches container will result in many lines of small crystal, okay, whenever we deposited the material. So this basically this two process was happening, okay. So if we think about the look at here, this distinguish between these two process or a difference between these two process. So what will happen exactly? The homogeneous nucleation takes place without the presence of any impurity atoms, okay. Means this process of nucleation was happening without the presence of any impurity atoms. It means in homogeneous nucleation there is not required any other external impurity, any other external particle, okay. But if we look onto the box of this part, nucleation takes place in the presence of impurity atoms, okay. And when impurity atom was formed because of impurity is nothing but a extra other atoms was inserted onto the surface, onto the substrate, getting my point. And during that time, if the impurity of that particular atom was inserted, nucleation takes place, okay. That is the heterogeneous nucleation was formed. And if we look in this second stage, it is an ideal case of nucleation and occurs in a pure metal solidification, okay. Why it is called a pure metal solidification? Because because we already discussed it recently, because there is not required a foreign atoms, okay. Means the pure material was formed because the pure material was formed or was inserted or was deposited onto that substrate, onto that surface of that substrate. Okay, and if we look into the sub part of heterogeneous nucleation, it is found in actual practice and occurs in all metals and alloys. Okay, so during the homogeneous nucleation process, there is required a pure metal solidification, but here we can use a metals as well as alloy also. Okay, now nucleation may be initiated at any site within the liquid melt simultaneously. Okay, but in the portion of heterogeneous nucleation, what will happen? Nucleation is initiated on substrate surface. That is, initiation is not simultaneous. Okay, means nucleation is continuously happening. Nucleation is initiated on substrate surface. Okay, that is the impurity, and that thing was happening due to the impurity of other particles. Okay, of other atoms which are coming from some of the technical processes such as CVD, PVD, or any other processes. Okay, so look it into this part. This required higher degree of supercooling. Okay, and heterogeneous nucleation, this required lower degree of supercooling. Okay, so during the process of homogeneous nucleation, there is required some of the chilling process, some of the cooling process. Okay, and during the homogeneous nucleation time, if we want to create a homogeneous nucleation, that time there is required higher degree of supercooling. There is required a higher degree of supercooling, but instead of homogeneous nucleation, if we think about the heterogeneous nucleation, it requires lower degree of supercooling. Okay, and it is a slower process, and hence larger grain size is seen after solidification. Okay, during if the homogeneous nucleation was formed, okay, so that time that process was very slow. Okay, but larger grain size is seen after solidification. Okay, larger grain size means if we put our deposited film, whatever homogeneous nucleation was formed, and if we remove that uh, substrate, or if we remove that film and put it onto the scanning electron microscope, or put it into the transmission electron microscope, and if we see the size of grains, okay, if we see the size of grain, or size of particles, at that time we can observe that the larger grain is found after the process of solidification. Okay, but if we talk about the process of faster process of heterogeneous nucleation. Okay, so if we think towards the side of heterogeneous nucleation, so this process is very faster than the homogeneous nucleation, and hence smaller grain size is found after solidification. Smaller grain size means what? The finer or very thin layer. Very thin means we can say that the layer in between the less than 10 nanometer of that thickness. Okay, so it may be a very smaller grain size. Okay, we already discussed the crystallite size, grain size, and particle size, the difference between that. Okay, and if you are unaware about that, so definitely I will teach you the difference between the grain size, crystallite size, or particle size differences. Okay, so that uh, these are the process of heterogeneous nucleation and homogeneous nucleation. And if we look the last point, the critical size of nucleus required is larger. In the section of homogeneous nucleation, the critical size of the nucleus required is larger, but as compared to homogeneous nucleation, here required a smaller critical size of nucleus. Okay, look at here. Okay, so this is all about the difference between the nucleation processes, that is the homogeneous nucleation and heterogeneous nucleation. Okay, so the growth process thus may be summarized as consisting of a statistical process of nucleation. Which process? That is the statistical process. Means the homogeneous nucleation form and heterogeneous nucleation form. These are the this concept are slightly correlated with the thermodynamical processes or with the type of thermodynamical concepts. Okay, so dependence on the nucleation on growth parameters. Okay, so we will try to understand the concept of dependence of nucleation on the growth parameters. And before going to discuss this parameter, we have to focus on the type of nucleation. Okay, means how nucleation was formed. Okay, so the growth process thus may be summarized as consisting of a statistical process of nucleation, or it may be happen as surface diffusion control growth of a three-dimensional nuclei and formation of network structure and its subsequent filling to give a continuous film. Okay, so depending on the thermodynamic parameters, whatever discusses or whatever I talked recently, that is the thermodynamic parameters for processes of heterogeneous, homogeneous nucleation or some kind of other processes. Okay, so depending on the thermodynamic parameters of the deposit and the substrate surface, the initial nucleation and growth stage may be described. Okay, so we will try to move towards the types of nucleation of the thermodynamic parameters. Before going to discuss that point, we will focus on the point of depending or dependence of nucleation on growth parameters. Okay, so here during the process of nucleation or during the process of growth of that particular nucleation of external material onto the surface of that substrate, the surface substrate temperature and deposition rate is also very important key points. Okay, very important parameters. Okay, so substrate temperature, the critical nuclei size increases with temperature. Okay, so whenever we are going to deposit a material onto the substrate of surface, that time temperature phenomena or temperature parameters are very important point, means it plays a very key point. Okay, if the increases the temperature, the critical nuclei size increases. It means the uh, growth of nucleation was formed very rapidly. It means they enhance the grain size. Okay, means what will happen? It forms a, we can say that agglomeration process was started if we increase the temperature, or sometime the agglomeration process was eliminate, or we can say that it at that particular time if we increase the temperature of that particular substrate, so at that time the size of that particle, size of that nucleus can has been increases. Sometimes it might be decreases, but maximum time it happens to increase the critical nuclear size. If we increase the temperature, the critical nuclear size increases with respect to temperature. Okay, and the barrier of nucleation is greater with increasing temperature. Barrier. Okay, so you have to focus on this point. Barrier of nucleation is greater with increasing temperature, so that during the process of nucleation it plays a very crucial role of substrate temperature and deposition rate. Okay, deposition rate means what? How fast or how slow we are going to deposit a material onto the substrate or onto the surface of that substrate. So deposition rate means what? The critical nuclear size decreases with increasing deposition rate. Please focus on that point. The critical nuclei size decreases. Okay, nuclei size means the size of that, we can say that the size of that particle or size of that whatever atoms we are deposited. Okay, or we are planning to deposit it. Okay, so deposition rate by using the external technique, by using the external technique we are planning to deposit some kind of material. At that time the critical size of nuclei decreases with increasing deposition rate. If we uh, if we decrease the deposition rate, the nuclei size get increases. Critical nuclei size get increases. This means it means this process is plays a vice versa role. Okay, so again the barrier for nucleation is smaller with increasing deposition rate. Okay, here in this process, if we increase the temperature in this process, if we increase the temperature, the nucleation is greater. Barrier of for nucleation is greater, but here barrier for nucleation is smaller with increasing deposition rate. Okay, so you have to keep in your mind that the substrate temperature and deposition rate is very much important, very much crucial or key points which plays to growth in growth onto the substrate or surface of that thin film. It means the dependence of nucleation on growth parameter. These are the two very important parameters, that is the substrate temperature and deposition rate. Okay. Now recently we are say that the growth stage may be described as these are the processes depending on the thermodynamic parameters of the deposit and the substrate surface. The initial nucleation and growth stages may be described as these are the three thermodynamic parameters was happening. Okay, that's why I'm talking about the depending on the thermodynamic parameters of the deposit and the substrate surface, the initial nucleation and growth stage may be described. Okay, and that type is nothing but a first one is Island type, that is called Olmer Weber type. Okay, so second is the layer type, that is called Frank van der Merwe type, and C is the mixed type, that is called Stransky Kranstano type. Okay, these are the three types. Okay, so what will happen of that three types? Okay, so if we think about the Island type, that is this type. Okay, that is this type. So Island type, that is nothing but a Wolmer Weber type. In this case, the rate of lateral growth at this stage is much higher than the perpendicular growth. Okay, and the grown nuclei are called Island. Grown nuclei. Okay, there are this is the first uh, first stage. This is the second stage. There are nuclei and nuclei was attracted towards each other, and they are in second stage they are very closely or very closely compacted or very closely attached with each other. Now after that, what will happen? The grown nuclei was formed. Okay, and grown nuclei means another growth was started. Okay, and if the substrate vapor surface energy is larger than the other two combined, a smooth film will form. Okay, during the Island type or Holmer Weber type, very thin layer of smooth film was formed. Okay, you can see here this processes. Okay, this is the pictorial images. Okay, and we can observe that, we can see that the how this smooth film will form. Okay, and layer growth will occur. Okay, if we want to deposit one more layer, if we want to deposit one more layer, so it is possible to growth. Okay, and the film weights the surface to lower surface energy. Okay, weights means some of the dry film. Now the B layer type is nothing but a layer type. That is B type is nothing but a layer type. Okay, and layer type is another name, or another name is that Frank van der Merwe type. And what will happen in this type? The total surface energy of the film interfaces is larger than that of the substrate vapor interfaces. Okay, so that this process was happening when the total surface energy of the film interfaces is larger than that of the substrate vapor interface. Okay, means whatever amount of nuclei was already present inside the substrate. Okay, so the total surface energy of the film interfaces is larger than the substrate vapor interfaces. Substrates means whatever nuclei was already available. Substrate means the film substrate. Okay, the material balls up to minimize interface with the substrate. So as compared to Island type, it happens a uneven growth. Uneven growth means some of the atom was deposited in the different portion of substrate. Some of the material was deposited in the another substrate. Okay, and some of the deposited onto the another corner of that substrate. Okay, so that these are the type of what layer type diffusion. Okay, so slow diffusion was formed. As compared to other, it happens a very slow diffusion as compared to what Island type or mixed type process. Okay, so that if we think about or if we look onto the side of mixed type or Stransky Krasnow type, so the structural evolution of the film is now decided by the ability of atoms on the surface. Okay, so mixed type, what will happen during the uh, mixed type or Stransky Krasnow type? So microstructure evolution was formed. Microstructure evolution was formed. It means the deposition layer is in the range of higher as compared to other of that two types. Okay, so initial layer growth was formed as compared to A and B part. Here the initial layer growth was formed. Okay, so the structural evolution of the film is now decided by the ability of atoms on the surface. An atom is the grains to move along the grain surface and between the grains. Grains means this part. These are the number of grains. These are the number of size of that particles. Okay, these are the atoms. Okay, not a grains. Okay, but in between these two atoms, there are some boundaries. In between these two atoms, there are some boundaries. I will draw here. This is the black portion. Look it into this area. Okay, this portion in between these two atoms there are some boundaries, and that boundaries is nothing but a grain boundaries. Okay, and the nucleation and the subsequent combination of the nuclei lead to the final film microstructure, and this morphology is influenced by substrate temperature, or might be a deposition rate, or it might be a geometry, or sometimes the desorption or bulk surface diffusion also possible in the type of mixed type Stransky Krastow type method. Okay, so changes into the island growth after the few monolayer. Okay, if here some layer was formed, so it might be possible to transfer the stage of island type. Changes into the island growth after a few monolayer. Okay, after the few monolayer type, the mixed type was changed towards the type of island type. Okay, the initial layer is strained to match the substrate, and after a few layers the strain is relaxed. After a few layers the strain is relaxed. It means if we deposit number of layers, okay, look at here, this is the first layer, this is the second layer, this is the third, fourth, the fifth layer. Okay, so it means that uh, 4 number point, after a few layers the strain is relaxed. Strain means they are attracted atoms, they are relaxed. It means there is no other process or there is no other movement was happening. Okay, so this is all about the nucleation process. Fine.